Okay. And then KJ's back.
Yeah, KJ.
We are in section 3.4, and all of chapter 3 I've been saying is about puzzles. Kind of. About puzzles. If you're trying to solve a puzzle, if you're trying to win a game, you have to know how to play. Well, usually you do. Sometimes pure dumb luck can get to the answer, but we know in math that's not necessarily the best route to take. Jaden.
No
Wi-Fi?
Someone give him a hotspot.
Is it not like it's just
If you have unlimited data, you can give a hotspot.
I do. I got you covered.
Jaden, I think it's accessible for you to sign into. I just don't have it off the top of my head.
Okay.
I know it's HCS.
I won't give it to anybody, I promise.
Yes.
I make my password really easily. Shoemaker?
Shoemaker.
Shoemaker?
What?
Oh, Shoemaker.
No, I didn't hear what you said. Okay. I think I'm getting it. Yeah, take your time, guys.
I'm trying to find the notes
Yeah.
come up on here.
Yeah. I was showing Jaden how if you can get the PDF and you can just like do the examples and not have to worry about writing. So I don't mind that. But guys, what have you written down so far? A strategy to tackling these problems. Now, this doesn't have every single possible, I don't know. Am I teaching you how to add and subtract and multiply and divide? No. Right? I don't have everything that you might possibly need. Does it show factoring? No, I don't have everything you might possibly need, but I have like a general approach. So, general approach. Number 1, isolate. What? Oh yeah, duh, get x by itself. No. Before we get to that, that's at the end of the problem. Isolate. What are you trying to isolate? Do you guys see it? The exponential or logarithmic piece. Can I get my marker out? I want yellow. So before we can even get to the x, which is the goal of even Algebra 1 kids would be like, yeah, get x by itself. They know how to get x, or they know what they're supposed to do. And you guys will too. Yeah, you want to get x by itself, but how? Okay. Try to isolate the exponential or logarithmic on one side of the equation if possible. Try to isolate, which could include, ready? Which could include
It's a lot of popcorn.
what we saw yesterday. Alex, please focus. Condensing. Because condensing, isn't it getting the logarithm in one logarithmic place instead of spread out? Do you get it? So part of isolating could also be condensing, something to keep in mind. One-to-one property, he's awesome, he's easy, but he's only sometimes possible. He's only sometimes possible. Remember, we love it if we can get like bases to match of like a to the u equals a to the b. We can say like, yay, u equals b. We can get rid of exponential that way. Or if we have log base a of something equals log base a of something, we love that because we can do something equal to each other. But guys, quick heads up. This is usually only true for the easier problems, so you're not going to get stuck with the one-to-one property. Like you won't get stuck there. You're going to get stuck on number 3. So number 1 can be tricky. How to isolate, how to condense, how to get down into one place as far as the log or the exponential where the x is stuck. And then number 3 is tricky too, because you're going to have to undo. And undo, the name of the game is inverse. I showed it to pre-cal yesterday where I showed you guys. No, I showed the pre-cal today, where I showed to you guys yesterday. Remember, those 3 buttons on your calculator, you have ln, you have log, and then you have square, right? Aren't they on top of each other?
Yeah.
But what is going on when you hit second ln, or second log, or second square? What's above? Inverse. So how do I undo an ln with an e to the power of? How do I undo a log with a 10 to the power of? How do I undo a squared with a square root? They're all inverses. How to undo.
Oh, I figured it out almost.
So, the wording can be read 2 different ways. Every year I have to choose which way I want to go. With logarithmic, if you're given a logarithmic expression of something, so you can just throw in whatever nastiness you have going on. If we want to, we can go ahead and throw in an x. If we want to undo a log, remember, we have to raise it as an exponent of an exponential. That's one way to undo a log. The other way, or transform. That's a math word. Let's do convert to exponential form. Depending on your brain, you might think of one way over the other. Sadly, this can't always take the place of that, but sometimes it is a good substitute. I had a BC kid tell me yesterday that he learned how to do this using a snail. So I'm going to put a snail in parentheses, and I'll see if I can show you what the snail is today. And then exponential. What if you had an x stuck in an exponential?
To a log.
Yeah, you can undo it by a log. But there's actually more to this one too. Or the other way to get rid of the x, because remember these can cancel and I get to the x, or these can cancel and I get to the x. But the other way is I can actually take any log, including like an ln of that expression, and the x would come down in front, which also helps. So either you get rid of everything and get to the x, or the x comes down and you can divide and get to the x. There actually are a couple different ways to do that one too. And get to the x, get to the x, or get to the x. So,
Misty,
we're just going to play with as many examples as we can.
where do you go?
Oh. Are you in the whole class?
Yes.
Go to the... Oh. Hey guys, sorry, you're just staring at me. Can you try to solve those two problems? Hey, use the one-to-one properties. It's going to feel like review because you kind of saw problems like this earlier.
Bless you, Cassie.
Huh?
In case it doesn't load.
Yeah, that would work.
That might be faster too with less thinking that your tablet has to do.
I have an iPad. Anyone else used to have an iPad mini?
No.
Still have it. I still have an iPad mini. It's just in my drawer. All the way at the bottom.
There's no dash in your Heritage Warriors email, right?
No.
Sophia, thank you, Jaden. Bro, are you so small, bro?
Oh my, that's must.
It's just their smallness.
It's like 100.
Alright, check in your groups if you guys have solved it. One-to-one property. Remember, if we can make the bases match.
I'm gonna connect to your hotspot.
Why?
No, don't connect because then Jaden has lower,
Yeah.
whatchamacallit, connectivity. Is that
I
what
have
I'm trying to
one
say?
bar.
Better
That's
not
the thing,
today.
right?
I guess it's like yeah. Isn't whack.
This end?
Yeah, try to refresh if you're in your
Mr.
email.
Hampton. Mr. Washington.
So just sign into like my.
Your Heritage Warriors,
Okay,
yeah.
Mr. Hampton right now.
Because 2 can go in 8. And 8 will be. I think I did this wrong. 6.
Here, Boomer. Boomer. There's some questions. Yeah.
Jane, did you get it?
It's the book.
Okay.
Unless I did.
I don't think I did this right. Okay.
It was easy.
Yes, I got it.
What'd you get for? I got X equals 3.82.
She said use the one-to-one property. You might kind of know.
Cassie. The second one you got 3.2. That's just
Alright, can I play?
Welcome back to Traffic Feud, everybody.
Got it.
Got it. Okay, here we go. Well, guys, the first one-to-one was. Of course, I start coughing as soon as I can start teaching. Okay, take it away. Letter A. Woo! One-to-one property. Sophia, this one was easy though, right?
That's gonna
Oh,
take out
no,
the
I
X.
did that one.
Okay, because bases match, so then we can go ahead and we'll wait a minute. Hold on. How do you solve something like this?
Just
Do you
bring
have
the
to
X
square
out the
root
side.
it? Do you have to? What?
Bring the X to the other side.
Oh, there we go. Get everything. Oh my God. Get everything.
Math is not working.
Bird alive.
0 equals x squared minus 3x minus 4. The x method, we have negative 4 and negative 3. You guys hopefully did. A negative 4 and a positive 1. That got you to?
4, negative 1.
Because we know that this signifies factors, right? And we still need to solve for the zeros. So x equals negative 1 and... Woo! Exponential functions. Pause. The domain is all real numbers, which means legal, good. I said that for a reason, because logarithms, not everything is legal. But for exponential, domain is all real numbers. He goes swoop, forever left, forever right. Everything's legal, so those two are legal answers done. Now, I said one-to-one property. Why? But 42 is not a power of 2. But you weren't supposed to start by breaking down 42. How are you supposed to think? How are you supposed to start? Divide by 3. You get 2 to the power of x is equal to ooh. Ooh. What's the problem? Break down 14, 2 and 7. Now what?
You gotta use a log-based formula.
I have multiple options, but question, is this a super basic, straightforward one-to-one property?
No.
Well, maybe I was mistaken in saying one-to-one property. So good job getting stuck, Sophia. So if we can't do one-to-one property, what could we do? Yeah, we could do the inverse. We can get rid of the 2, but how do we get rid of the 2? Can you guys check down here real fast? We have 2 options. One is log base 2, and one is ln. Does anybody have their book on them? Actually, don't worry. I have a webcam and I have a book. I want us to look at answers really quickly to section 3.4 odds, and I want us to see, okay, do they have a lot of log bases, or do they have a lot of ln's, or do they have a little bit of both? Okay? Because if the answers have ln's, maybe we should do it this way. If the answers have log bases, maybe we should do it this way. Our answers will look differently. So check it. Bloop, bloop.
Hover cam.
This is section 3. What? 3.4? Okay. Section 3.4. If you have your book, you're looking. If you don't, you are looking up here.
Yeah.
All right, let's check it.
It's the hover cam.
Alex, Sophia, this is really important for homework and what approach we're going to take. What are you seeing all these answers so far?
They're like simplified.
Oh my goodness. I only see ln's and common logs, don't you? Okay, wait. That was the beginning of homework. Maybe it gets different. Hold on. Oh, dang. Guys, what else do you still see?
Same thing.
I see tons of ln's. Why aren't they using log base 2s, log base 3s, log base 7s, log base... Here's why. If you look at a science or a chemistry textbook, or if you look at any sort of textbook teaching exponential growth and decay, you're only going to see ln's. Maybe it's partially because there's an ln button in your calculator, so it's faster than going to find log base, and maybe it's because ln's are based on the natural number e, and e/ln's are a better reference point rather than using lots of different types of logs. So here's the dealio. Could we have done log base 2 of both sides? Yeah, we could have. Would we have been wrong? No, not at all. It would have been totally fine for us to throw in a log base 2 and a log base 2. And why did you want to do that? What can you do right now with the 2, with the log base 2? Reduce. They undo each other. They cancel each other out. But the problem is, guys, is this how the answer is going to look in the back of the book?
No. You have to
Yeah.
calculate
You
it.
can use the change of base formula to get the ln version. And you would get x is equal to ln of 14 all over ln of 2. You can use the change of base formula. Well,
Does it have to be log?
the change of base formula says I can take any old base and make it into a new base. So we actually wrote it in our notes if you guys go find it. And you can change it to, except I didn't stop here. I said so. You can change any log to a common log, or you can change any log to an ln.
Oh, we should just do all this stuff. Oh, I see. Never mind, I see.
Does that make sense? I'm just plugging in.
So
But
We use the
E
base, so
E
it's
is just the
same.
new base. Well, it's not written the same way common log base 10 isn't written. But there was another variation, another way to go. Hold on, Alex. Give me 1 second. We could have also taken this. Guys, check what I wrote in our notes. And instead of doing log base 2, which is nice to simplify, like to cancel out, but it's nasty for, it's kind of nasty or kind of hard for making it match the answer in the back of the book. We could have just said, okay, fine, I know you like ln's. And if we say, fine, I know you like ln's, what's the power property of any logarithm let me do if there's a log?
In the front.
that's what you
This way you don't have to remember the change of base formula. Either way it works.
So you're allowed to divide there, but you can.
Well, I'm not dividing by just ln, I'm dividing by its entire expression, ln of 2.
Oh, that's really good.
So it's not like one of those empty ln's where it's like, what are you doing? It's like, no, it's ln of 2. X times, I can divide. It's not an of, it's a times. Because of the power property that says bring it down and make it multiplication.
So are we not allowed to do the calculator part when we get like a decimal?
Well, that's a really good question. Because you guys just saw in the back of the book that every single one of those had decimal answers along with it, right? Is that going to work? There we go. Every time the book writes an answer, it also gives a decimal. Every time the book gives an answer, it also writes a decimal. Why? Because you could plug in this example, you could plug in your log base 2 of 14 into your calculator, and guess what decimal it would equal? The same. Does that make sense? So technically, could you box your answer if its decimal matches the back? Yeah. It's just written in a different form.
So if on the test we didn't put it like that, we put it as a decimal, we get it wrong.
Multiple choice answers, there will be decimals that go along with it, and if there aren't, which this would take a little extra time, I have to look at the test to make sure that before we get there, we have the correct strategy. If the decimals aren't there, like in the back of the book they are, right? If the decimals aren't there, couldn't you technically plug in A and B and C and D and E, find the decimals and make it match? Right? Now, it's nasty, it would take extra time. But I think if I remember right, Alec, it's not written with decimals on the test. But you could always plug it in, find a decimal, make it match, but think you'd have to test A and B and C and D. So in preparation for the test, if you realize that LNs are the preferred form, Like scientifically and mathematically, LNs are the preferred form. You might not understand why, but they are. You can practice trying to make it match now. But if you have the decimals, if worse comes to worse, it might take you extra time, but you should still get to the right answer. Is that cool?
Yeah.
Great question. Super great question for as far as like trying to get answers right in the test. So Sophia, 1-to-1 property, was it as easy as that?
No.
But what if that had been a 16?
That would have been
Would have been gorgeous, because 16 would have been 2 to the power of 4, and x would have equaled 4, we would have been done. So 1-to-1 property is good, but it's only really there for easy problems. You guys seeing it? So let's keep going to harder problems. I don't, because I know this is what the answer would have looked like. But if yours looks different than the back of the book, you would have wanted to see the decimals and whether or not they match. Does that make sense? Okay. Boop, boop. Which, guys, I mean, I know it's rough, and I know it's kind of like, this is weird. Like, there are different ways the answers can appear, but you're just kind of getting introduced to, in math, you can have a correct solution for more complicated problems that looks differently than someone else's. But it could still mean the exact same thing. Oh, there's a life lesson in that.
We should start talking about that.
Not if I want to expand it. Well, it's dangerous because in our culture it's like, oh, hey, whatever's right for you is right for you. Whatever's right for me is right for me. That's not what I'm saying. I'm not saying that everything is right and it doesn't matter how you write it. I'm saying there are different expressions that mean the same thing at its foundation but look differently. But don't you have to know the meaning behind what you're looking at to be able to know whether or not it's right? Now, for us, it's easy. Laura, let me show you what we're talking about. For the problem that we just did, it wasn't as easy as 1-to-1 properties. Well, one of them was. The E one. Oh, I'm going the wrong way. So that's not helping me. This one was nice because it's like, hey, they match. But this one was nasty because 14 isn't like a pretty power of 2. So then Sophia's like, what on earth do we do? And we were like, well, log base 2 would undo the 2. So we're like, sweet, that's an answer. And to be totally honest, guys, was log base 2 of 14 an answer?
Yes.
Yeah. But then I went to the back of the book and I was like, uh-oh, but watch out. In our notes, I actually said there are 2 ways to solve. One is with a log base that cancels. The other way is scientifically, mathematically, ln is a preferred log and uses a property to get there instead. I'm going to go show them in the back of the book. Look at the answers and what do they look like? They're not using this log base 2 form because scientifically, mathematically, that's not very common. That's not used very much. This is used more. Without me going into explaining why, there's this dilemma then. We could have a perfectly correct answer, but they wrote it a different way. And so in the back of the book, we have those decimals. And so it's nice for us because we can just plug it in and be like, decimal to decimal. Ha-ha, look, they're the same. Look, I was right. No big deal. We talked about the test a little bit. Uh-oh. How are the answers going to look on the test? You can always plug in and see if the decimals match. If the decimals match, you have the right answer just written in a different form. So what's nice for us is we can just plug it in and be like, whew, does the decimal match? Yes, all right, I'm good. In life, you have to ask yourselves, do your words match? No, that doesn't work. Some people use words and they mean different things. Do your meanings match? So you have to actually have conversations that are more in-depth and say, what do you mean when you say discrimination? What do you mean when you say feminism? What do you mean when you say that's just like scratching the surface. But anyway, what do people mean when they say? But for us, we have a calculator. If you plug that one in and if you plug that one in, they're the exact same decimal, we're good. Move on. You've got it. Okay. So then we get to these ones. Which one looks easier?
The A.
Oh, does it? I thought B looked easier. Okay, A looks easier.
It looks a lot easier.
What's X equal? Don't do mental math. Just get rid of the ln. How do we get rid of the ln? E. Okay, so one way is we know the base of ln is e, so e to the both sides. Remember, exponential to the log cancels out. So then x is equal to e squared. But can I show you the snail?
Of course.
Okay. I count BC kid. Well, I mean, we could just say that's enough and we're done. But a Calc BC kid showed me a way that they learned how to change from logarithmic form. It has a log, yeah? Logarithmic form to exponential form. I know Mr. Che showed you this last year.
Papa Che.
But not the snail. Ready? The snail says, take your expression with whatever log, well, ln has a base of e, right? And the snail says, well, that's a bad snail. But you guys get the idea.
Looks like what's his face?
I know. Hold on, my corkscrew got
Emoji
too
thing?
tight.
What's his name? You know, like the what's it called?
E
Is that Lucas Strauss?
to the power of 2 is equal to, it's just how their teacher taught them to remember.
That Lucas Strauss.
What?
The emoticons.
And if you want, you could technically have the snail go around the X. That might be even more fun.
The face that Lucas is always drawing with the emoticons.
Okay, thank you, Alec. You can make it that too. But anyway, if you want, I guess you could also like encapsulate the X.
Oh, I see.
There we go. You can do it that way.
Why didn't Mr. Chase show
Get us?
Okay, I never learned the snail trick of remembering. I did yesterday. But anyway, e to the power of 2 is equal to x. Oh, hey, look, it's the same thing. Anyway.
How would that work for like multiple?
Well, that's the problem. You know how the one-to-one properties for the easy ones? The snails for the easy ones. But it's one way. All right, what's cool about letter B?
They're the same base. Oh.
They're the same base. So can't I say that? Okay. We like the one-to-one property when it, like the smart board, we like it when it works.
Hold on.
Okay. Minus x, we get 4x. Plus 1, we get 8. Guys, we're not scared of these types, right? These ones, there are different ways to go about it, but maybe one of the ways clicks better for you than the others. But harder problems are coming. Focus in. Let's go. Are we good?
Boomer o'clock.
So wait a minute. Why is every single problem in homework going to say to approximate to 3 decimal places? However you write it, your decimal should match, right? If your decimal doesn't match the back of the book, then something went wrong. Okay, remember this could show up, these answers could show up in different ways.
It's on the side.
Okay, so number 28, what do you guys think we should do first? 8 times 3 is 24. Awful, illegal. You guys were right. Divide. Good? Oh, red. I mean, 4 goes into both, so I have 10 over 2. Okay, 48. That's easy. So math, I don't even know. But what is sad?
What is that left?
Guys, you're amazing. There are 2 different ways to go. Both of their decimals will match. How do we get to the x? Okay, if your brain thinks log base 3, then go for it. I don't mind. Log base 3 of 3 to the 6 minus x equals log base 3 of 5. Are you right? Absolutely. Is it going to get you to a correct expression of the answer? Absolutely. As long as you correctly solve 6 minus x is equal to log base 3 of 5. What's the other way you could have gone? What's the preferred scientific mathematical version of log?
Bring the thingy to the front.
ln. So you could have done ln. If you want it to match perfectly with like a multiple choice answer without having to do decimals. If you want it to match perfectly the back of the book without decimals. You would have taken an ln, which allows the power to come down. 6 minus x is equal to ln of 5 over ln of 3. Now I know we're not done, but do these two mean the exact same thing? Yes, because of the change of base formula that says a log like this can be written like that. So yeah, they mean the same thing. They're decimals. Wait, we're not done. How do we get to x? Okay, a lot of you are thinking subtract 6. You're right. Just be careful. My brain, to be honest, would have added the x and subtracted the log. It's easier in my brain. But you're right, most of you would think -6. Just be really careful. I can't combine those, right? They're not. Okay. So it's going to be -x equals. Your way just takes a little bit more mental gymnastics because now I have to divide everything by a -1, which leads to the same thing I had a second ago by adding the x and subtracting. It's a little bit easier as far as getting the right one. Dividing by a negative would flip the signs. And we usually try to write the positive guy first and the negative guy second. But either way. Do these look the exact same? No.
Is that it?
But do they mean, well, x is by itself, yeah, good. They mean the same thing. If you plug them in your calculator, they will get the exact same decimal. You guys are getting the point as far as y decimals, right? Depending on how you write it, you might need it. Whoa! 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 There's a 2 and a... It's a different thing. Right? How are we supposed to do that?
We killed them all.
Hold on, we're playing with harder puzzles. Where's your competitive spirit? Oh, we have some more. We have some more. We have some more. We're still 9 minutes, 8 minutes.
I can assume.
Okay, hold on. Come on. Some of you are mad at this problem. I'm mad at this problem if I were you. Because they have different bases. I can't do a log base 2 and everything's okay. I can't do a log base 3 and everything's okay. Oh, maybe that's why they use ln. But what happens if I do ln on both sides? Log base 2 is not enough. Doesn't work for him. Log base 3 is not enough. Doesn't work for him. What happens if I do this? I can bring both of them down. Doesn't cancel. Doesn't look all nice and pretty like that one. But I can at least get to my x's. I can at least get to my x's. So I end up, okay, hold on. There we go. So I have x times ln of 2 equals.
X plus 1 ln.
Hold on, you're not going to like me in a second. I'm trying to think of the easiest way to go. It's not about whether you like me. I'm trying to have you understand that. Can I do x ln of 3 plus ln of 3?
What?
Well,
What you do?
when I bring down the x plus 1, what does ln of 3 need to do? I know. I told you you weren't going to like me, but that's fine. Do you understand the math? I bring this down, it's in parentheses. It's one grouped binomial. When I bring it down, ln of 3 is a coefficient, is a number being multiplied. It has to go to both the x guy and the 1 guy.
But then why is the 3 with the x?
Well, it is.
It's not. It's in between the ln. Why is it 3x ln? Well, why is it ln 3x?
Okay, so never mind. That was bad, and we didn't understand it. Hold on. We get this is coming down?
Yeah.
Okay. So then, if I show the work, this makes sense?
Yes.
This is a number I could plug into my calculator and rewrite as a decimal. Please don't, but I could. What happens to numbers outside parentheses? This is ln of 3. If I write ln of 3x, what does that look like? Ln of, but it's not. I don't just randomly bring things inside ln's the same way I don't randomly bring things under square roots. So the x is not attached to an ln. The x is separate, and to show that, we write it in front. Because it's confusing if we write it at the end. This is a number. I could multiply it by the x, write it as a decimal, and it would look like a 2x, 3x, I don't know, something awkward x. But I can't write the x here, or else it looks like ln of 3x, when it's not. It's ln of 3 times x.
Okay.
Plus. Well, 1 times anything is itself. One's in front, technically. I understood one.
So if it was like a 2, then 2.
Then it'd be 2 ln of 3. Because we don't want ln of 3, 2. That doesn't make sense. That's a plus. Okay. Where are the x's? 2 places. Oh, that's okay. What happens if we just subtract? Why on earth would I move the x guy to be with the other x guy? Oh. Well, if they're together, what can I pull out? Don't pull out limbs, because he has a 2 and he has a 3. I can't pull out the same one, but I can pull out the x. So why would the final answer in the back probably be ln of 3 divided by ln of 2/3? Now don't worry. If you divided and got a decimal, it would match this decimal, but what did they do? They divided, I get that, but what else did they do? They saw the subtraction and they said, there's a property for that. Ooh. They used the quotient property. But guys, don't worry. If you didn't see that, or if the back of the book had that, your goal is to make the decimals match. So if you had written this down and you had plugged into your calculator, the decimal would match and you would have been totally fine, and there was no problem. There is no problem with you having that.
Why is it over? Why is it that over?
Division. It's just x times something, and so multiplication is undone by division.
So if we just put that.
This is fine.
Okay.
Yeah. I was just showing what the back of the book would have probably had, because they would have put these together. But remember, you're doing decimals. Why? Make the decimals match. Maybe yours looks a little differently. But this one, guys, a log base 2, log base 3, it wouldn't have cut it. It wouldn't have done what you wanted it to do. You need another log to let both powers come down and then play. If I were you, if you had like a colored pen highlighter, I would highlight that problem. It's a very typical nasty problem. What if the bases are different? What if the bases are different? I already did that one. Let's do this one. He's probably the next nastiest one. In order to do this problem, and some of you are starting to freak out, question. If I had this guy, what do I do when I have a power to a power? Would I ever write that as x times 2?
No, 2x.
No, you would write it as e to the 2x.
Big brain.
Okay, so check it. It's e to the x. This is him squared minus plus. Does anybody see why I'm going to put an x over here? Squared minus 5 times single plus 6. This is a quadratic equation. Now, if you don't like it, you could technically say, I don't like the e to the x, it's messing me up. We can actually take them out for a second and be like, can I just look at you ignoring you for a second? Look at the whole expression, ignoring e to the x. It's a quadratic. I'm just trying to factor 6 and negative 5. And once I figure out that that's going to be, I think, negative 2 and negative 3, whether you understand why or how the e's are there in a quadratic or whether you don't, you could say, okay, I don't know what's going on. I like the u's because they're prettier. So u is equal to 2 and 3. Or whether you actually understand, oh, it's e to the x minus 2 and e to the x minus 3. So e to the x is equal to 2 and e to the x is equal to 3. Either way, eventually you end up with the same thing, which is not the final answer, but it is how to get to the final answer. Here, u, or e to the x equals 2 and 3. Here, e to the x equals 2 and 3. How do I solve? Well, guys, how do I get rid of e? You would have done the same thing here when you plugged in. And what do we end up getting? X equals ln of 2 and ln of 2. If I were you with a colored pen, I would mark this problem and say, when it looks like this, factor. It looks like that, factor. The next example. example, the only one we didn't get to is actually easier than probably any of the other ones we've done today. So I think you guys are good. Come find me if you have questions. Tonight, play with the puzzles and see if you can make the decimals, maybe even the form, but at least the decimals match.